Hey guys, and welcome back to another project video. Today's project is going to be a little bit special because today is my science fair project. I'm super excited for this and I cannot wait to get started. I have an awesome idea, like super awesome, and it focuses around the subject of rockets. I can make my own water rockets. I'm going to go gather my thoughts, get a few supplies, and I'm going to start building my rocket. Okay, so after much modifications and planning, I finally finished my water rocket. This is made from 2 soda bottles, as you can probably tell. Made the fins out of some plastic Tupperware and covered them with duct tape to make them look really cool. Got some electrical tape just for some security, I guess. So I'm pretty happy with the result. But anyways, so the next problem I have run into is, how do I launch this? As you saw before, I used a cork, but I found out that a cork is not the best way to do it, because there's too many variables that way. I can't have a certain PSI measurement, because sometimes it will launch at 30, sometimes it'll probably launch at 25. I mean, it could vary. I want a specific PSI so I can get the best results. Also, the cork will, since it's being like when the bottle is flipped upside down like this, the cork is in the bottom and all the water is on top of it, so it's soaking the cork, which is kind of wearing it down. So I mean, the cork is a variable, so I have to come up with a new plan. Unfortunately, I came up with a launcher made out of PVC pipe. So I'm going to take you outside and show you how I built it and how it works. Okay guys, here's the launcher for the water rocket. I will be taking you a little tour of how it all works and how it was put together. Alright, so the way it works is we start off with this electric pump here that is connected to the PVC pipe by this a part of a bike tube. You can see this was part of a bike tube, but I cut it off and attached it to the PVC pipe, which the PVC pipe is strapped down to these blocks of wood for stabilization, and it goes up here, and gets a little complicated, but these zip ties, they're for locking onto the rocket. So when let's see if we slide this on, so now you can see that the zip ties, the ends latch onto the rocket. And so next what we do, we take this PVC ring and we just put it up there like that, so it locks on. So when the pressure builds up in the bottle, it won't lift off unless I pull the string, which is right here. So for my experiment, I'm pumping up 30 PSI for every launch. So I decided to create this launcher just for a controlled PSI, because the cork method it varied, because it released at different types of pressure, and eventually the cork wear it out a bit. So this is more efficient. Okay, just to review, air pump pumps air through the PVC pipe, which goes into the rocket. The rocket is held down by zip ties and the PVC pipe tube, which when the air pumps up the bottle to a certain psi, I can then pull the string, which will launch it off. So I will give you a test run. Okay, so just for testing purposes, I'm only gonna pump the bottle up to about 20 psi. But for my experiment, I'm gonna be pumping up to 30 psi. So here we go. It's gonna be loud, so I won't be able to talk. Okay, now we're at 20 psi. The bottle is filled with air. Pull the string. And it launches. So as you can see, that went up all the way up there. I almost got stuck in the tree. I was scared there for a minute, but it has come down, and now we can get on with the experiment. Now, since this is a science experiment, we need a question to find an answer to. So what we're trying to find out for this experiment is, will more or less water affect the height of the water rocket? I am predicting that more water will make the rocket go higher, because if more water is in the rocket and the same amount of air pressure is pumped into the rocket for every launch, then with the water taking up space, the air will have a smaller space to fill than in an empty rocket. So with little space for air at a certain pressure, the air will force the water down the nozzle, propelling it higher than an empty rocket. Up here on the screen, you'll see a simple chart of my hypothesis. Less water won't propel the rocket so high, and then more water will make the rocket go higher. This chart displayed up here is where I'm going to be keeping track of all the information I need. So in the left column, there's the launch number, which there will be 5 launches for the 3 experiments. Every launch, the pressure is going to be filled up to 30 psi. The next column is showing how much water is going to be in the rocket for that launch. So there is no water, a 1/4 cup water, 1/2 cup of water, 1 cup of water, and 2 cups of water. The last 2 columns are where I plug in the angles that the tracking stations collected. So what they're going to do, they're going to follow the rocket up and record the angle. I will then take both of these angles, plug them into this equation, average both of them out, and I will get my height of the rocket. Hey guys, so we just arrived at the launch area. So we're just getting set up here. Launch pad right here. We got 2 tracking stations. Right where that water bottle is. The other one, my mom is standing. My 2 younger siblings holding the blue sheet. They're gonna try and catch the rocket before it hits the ground. So I'm very hopeful about this experiment. Hopefully all goes well. Okay, and here are the results for the rocket experiment. So the dotted line is proving my hypothesis correct. More water does make the rocket go higher, because as you can see, it's slightly going up. There were a few problems with this experiment. As you can see, with the first launches of no water, they went higher than the 1/4 cup water. This is because we were unable to catch the rocket, so it kept hitting the ground, which kind of bent the nose cone, which altered the flight pattern of the rocket, which altered the experiment. So next time I do this, I'm probably going to find a way to build a rocket out of a more sturdy material. But my hypothesis has been proven correct, that more water makes the rocket go higher. Hey guys, thank you so much for watching. This was an awesome project. I hope you enjoyed it. If you want to see more content, please click the subscribe button where you can see more of my project videos coming up. Thanks again for watching, and I will see you in the next project.